Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at radians. Now, radians are another way to measure the size of an angle other than degrees. There's a one-to-one correspondence between the measure of an angle in radians and the measure in degrees. So you might be thinking to yourself, well, why do we need both? And as you do more and more maths, you'll see that we just need radians to make things work, particularly the calculus of trigonometric functions. So what exactly is a radian? Well, if we have a circle here, and we have this sector where the radii, so the two radius, have the same length as the arc they subtend. When you get a situation like this angle here is said to have measure 1 radian. So we write theta equals 1, and sometimes you see this little C looking thing for radians. So let's figure out what fraction of the circumference is this whole arc. Well, if this radius here were r, we know that the circumference of the whole circle is 2 pi r. So what fraction of a circle is this? Well, this length here is also r by the way we constructed it. So it's r over 2 pi r. Cancel out the r's. This is 1 over 2 pi of the whole circle, this arc here. So that means there are 2 pi of these radians in a whole circle. What that means is 2 pi radians is equal to a full circle, which is 360 degrees. And of course, that means pi radians equals 180 degrees. So there are 3.14159 blah, blah, blah radians in 180 degrees. So if you want to go from radians to degrees, you simply times by 180 over pi. And if you want to go from degrees to radians, you simply times by pi over 180. So for example, pi on 4 radians, if you want to know what that is in degrees, all you do is times by 180 over pi. So you can use your calculator to do this. You can just cross out the pi's. 180 divided 4 is 45. Pi on 4 radians is 45 degrees. So of course that means something like pi on 2 is 90 degrees, pi radians is 180 degrees, and so on. If you have a measure in degrees like 120 degrees and you want to change it to radians, we just times by pi over 180. Now the problem with putting this in your calculator is your calculator, well most calculators, don't give exact values. So what you would do is just go 120 over 180 in your calculator, which is 2 over 3. So this would be 2 pi on 3 radians. Don't put the pi in your calculator if it doesn't have exact values, because it'll just give you a long decimal, which doesn't really do much for you. So of course we know some exact values in degrees, now we know them in radians. So if I wanted to know the exact value of, let's say, sine of pi over 6, well that is the same as sine of 30 degrees. Pi on 6 times 180 over pi is 30, so sine pi on 6 is equal to a half. Now you need to be careful because when you're using trigonometric functions sine, cos, and tan, you need to be clear whether the question is asking you about radians or degrees, and your calculator needs to be in the correct mode. Usually you'll see a box with an R in it if it's in radians mode, and a box with a D in it up the top if it's in degrees mode. So let's now use radians to calculate arc lengths and sector areas. So if we have a circle like this and the angle subtended here is in radians, we can easily calculate the arc length and the sector area. So the arc length is this length here, which we call L. It is just radius times the angle as long as the angle is in radians. So for example, let's say that R was equal to 4 centimeters here, and let's say that this angle was 135 degrees. Now 135 degrees, if you want to convert to radians, you times by pi over 180. 135 over 180 is equal to 3/4. So this will be 3 pi on 4 radians. When you're using this formula, theta must be in radians. So in this particular example, the arc length would simply be 4 times 3 pi over 4, and that gives you 3 pi. That is the exact length of this arc here. Of course, if you wanted it as a decimal, it'd be about 9.43. All right, what is the area of this sector? So a sector, remember, is where you cut out a slice of the circle and you go through the middle. So it's like a slice of pie cut out. So the sector area here would just be 1/2 times radius squared times theta. Now again, theta must be in radians. You can't times by 135 degrees here or you will get the wrong answer. So if you use your calculator for that, you'll get the answer is 6 pi exactly, or I think that equals about 18.85 or something like that. All right, let's now look at a harder question involving circles and radians. So we will use radians now to calculate the area of this shaded part, which is called a segment. So what we're going to do is find the area of the sector and subtract the area of this triangle. Now note, as long as this is the center of the circle, these two lengths here will be the same. The radius is always the same from anywhere on the circumference to the center. So because this is an isosceles triangle, 2 equal sides, it will have 2 equal angles here and here. Now you know that the angles in a triangle add to 180 degrees, but that means they add up to pi radians. 180 degrees is pi radians. So pi over 5, if you want to convert to degrees, is 180 over 5 is 36 degrees. So that means that this angle here, as well as this angle here, they're both going to be equal to 180 minus 36 divided by 2. They're going to be equal to 72 degrees. And in radians, times by pi over 180, that's 2 pi on 5 radians. 2 pi on 5 plus 2 pi on 5 plus pi on 5 equals pi radians, which is 180 degrees. So now that we have those angles, we can easily find the radius using the sine rule. So the sine rule for a side tells us side over sine of its opposite angle is equal to side over sine of its opposite angle. So just be careful when we're doing these calculations, our calculator will need to be in radians mode. So you know how to do this already. R will just be 10 times sine of 2 pi on 5 divided sine of 1 pi on 5. So putting this on our calculator, we get about 16.18. Thank God when we are doing side calculations involving the sine rule, there is no ambiguous case. And remember that we should check our answer, of course, because 10 was opposite a smaller angle, our answer should be larger than 10, which it is. So now that we have the radius, we can easily calculate the area of the sector and the area of the triangle. So I'll just call A sub S the area of the sector. So the formula for that is 1/2 r squared times pi on 5. Now, because r is not a nice number here, it's just approximately 16.18, in my calculator I'm going to go 1/2 times answer squared times pi on 5. I don't want to round this if I'm going to use it in a subsequent calculation. So the answer we get here, about 82.24796. I'm going to use a few decimal places because I need to use this in another calculation. All right, now let's calculate the area of a triangle. We know how to do that. It's just 1/2 times radius squared, so 1/2 AB times sine of C. So the only difference is instead of being 1/2 r squared theta, it's 1/2 r squared sine theta when we're calculating the area of the triangle. So putting this on our calculator, we should get about 76.9421. So the area that's left in the segment, the blue part here, that will just be this minus this, Our final answer for the area is going to be about 5.31, and we just write units squared. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.